Okay. So, the final example, example 4 from this section, we've got a similar setup. We've got three forces acting on a particle, all at different angles, and crucially this P and this theta are both unknown. So we've got two unknowns. And we're just going to go about it exactly like we've been going about all the other questions in this section. So we start off by resolving vertically. So remember, that means what? That's the positive direction, and we know it's in equilibrium, which means that they're going to have to be equal, the forces that are going up and the ones that are going down. So in that direction you can see that this will be a positive, it's going up, this will be a positive, and this will be a negative. Of course they're all going to have adjustments though, because to get to these vertical lines, none of them are going vertically at the moment, so we have to multiply by either cos or sine of the angle. So we start off with this one. We can see that this one is going away. This one would be going away from the angle of 30 as well, and this one would also be going away. So it's very easy, because we're going away on each one, we know that it's going to be sine. Yeah? Here's the 30, we're not going through the 30, are we, to get to the horizontal, we're going away from it to get to that vertical, we're going across the white space here. So in the positive direction we've got 140 times sine of that angle, so sine 45, plus 100 times sine 30. We know that must be equal to P, and then it's theta's here, so we're going away from theta, so it's P sine theta. So we can put the left hand side into our calculator, and that will give us an expression for P sine theta. So I've got 148.99. Okay, keep as much accuracy as you can at this stage, because we know that might affect the final answer if we round it incorrectly. Now we're going to the right. So if we go to the right, what we can see is that actually some of the signs are going to change. So right's our positive direction, so this is going to the right, this one is now going to the right, but this one is going to the left. So those two will be positive and they'll be negative. And they're all going away last time, so this time to go to the horizontal, they're all going through. This goes through the 30, the P would go through the theta, and the 140 would go through there. So actually if we go through, we have that is equal to cos. So therefore, start with the things on the right, we've got 100 cos 30 plus P cos theta equals 140 cos 45. Then I'm going to rearrange, so the things I don't know, P cos theta are by themselves, I'll do 140 cos 45 minus 100 cos 30. We'll see what that is. This is 12.39. It's two decimal places. So far we've got two equations, they both have two unknowns. Alright, so we've got a bit of a problem there. But anytime we have two unknowns and two equations, we're going to be solving them simultaneously. But we've got a P multiplied by a sine theta and a P times a cos theta. So we've got to think about how we're going to eliminate one variable from those equations. Anyone got it? Right, I'm going to divide the equation, well done if that's what you were thinking. So 1 divided by 2 will give us P sine theta divided by P cos theta on the left, and then 148.99 and 12.39. So the P's, why do we do this? Well, we do this because it will cancel out the P's. Right, P and P. Sine theta over cos theta becomes tan theta. And on the right, we've just got a number. I'll keep it as it is for now. Right, so then to get theta, we just have to do tan inverse of both sides. So theta equals .85.2. So three significant figures. But of course, the question didn't even ask for that. the question asked us to calculate the magnitude of P. So to find P, we're just going to put it into one of the other equations. So for example, equation 1, so we've got P sine 85.2, but I will use the full calculator accuracy that I've got. So I just do P equals 148.99 divided by that answer from earlier. So this is P is 149.5 newtons. Okay. So, we really should put that to 150 newtons to 3 significant figures. Everything in mechanics wants to be given as a final answer to either 2 or 3 significant figures. It'll say that on the front of the paper. So that's the end of the first lesson from the year 13 content. The key point is up here, right? If we're going away from the angle, we're going to be using sine of the angle when we're resolving it. And if we're going through it, we're going to be using cos of the angle. And that will stay the same for most of this year 13 content. Very important rule for you to get your head around. And to help you get your head around that, we're going to do exercise 5a. And we're just going to do a few questions from each part because they're all slightly different. So I'll write them down here for you. And then question 5, 6, 7, 8 and 9. And obviously they're a bit more challenging at the end. But these should be like the examples, follow the examples, remember your rule about through is cos and sine is away, and you should be fine.